Hello and welcome back to another episode of In the Spotlight. I'm Jordan O'Brien, editor of Electrical Review. Today, I'm pleased to be joined by Alastair Uren, Specification Sales Engineer at Socomec. Welcome, Alastair, and thank you for joining us today.
Nice to be here. Thanks for inviting me.
Why don't you start by introducing yourself, Socomec, and your role?
Thank you. I will do that. Thanks, Jordan. So, as you said, my name's Alastair Uren, Specification Sales in the London area for Socomec. It's predominantly. Socomec themselves are a fourth-generation family-owned French electrical business, about 900 million euros globally, really working in what we call the critical power area of the market. So UPS, static transfer switches, automatic transfer switches, a lot of switches. Metering and monitoring that we're going to talk more about today, and battery energy storage. They're our main business areas.
Sort of touched on what we're going to talk about today. I just wanted to dive right into that if we can.
Sure. No, I'm going to talk about optimizing energy management, but within that, we're going to talk about power monitoring, power quality, and MID compliant sub-billing, where you're billing tenants. So in terms of the agenda today, we're going to look at power monitoring and some of the drivers for energy efficiency, why you would do that. Just a reminder about some of the typical power quality issues. We're going to talk about MID for subtenant billing and the important aspects of that. We're going to look at, just very briefly, talk about where you monitor in your electrical installation, where you monitor, where you measure. We'll have a look at a brief case study. I'm just going to briefly overview our multi-branch metering system, DigiWare, towards the end and show you the selector tool, or at least talk about the selector tool that we have before we summarize at the end. So I'm going to start with power monitoring.
Some of our viewers will be wondering why bother monitoring your power consumption.
That's a good question. A lot of the reason for power monitoring is increased legislative pressure. There's a number of elements to this, but Part L, net zero, the cost of energy. It's also best practice. There are standards like BREEAM, where you can go for BREEAM Platinum in the design of a building, neighbours, where you predict all your utility usage, water, gas, and electricity, and then they audit you afterwards. And that's becoming a very popular standard to be used in this area. It impacts energy efficiency. There's another directive at an EU level specifically for data centers where they need to understand, it's called the EED, and they need to understand the Energy Efficiency Directive. And they need to understand a lot more of where their energy is being used, and they have to report on that. I think one key sort of point here is if you don't monitor, or you don't monitor in enough granularity, you're just measuring at the main income, or how can you understand your energy use? There's also whether you're using any solar arrays or battery energy storage integration, that's another part. Also, residual current monitoring, actual active monitoring, that's a requirement that's now illegal in Germany. It's a legal requirement. We think that will follow here. So not just guessing about your insulation level but measuring its performance. And then the whole idea of being able to, if you're not monitoring, you can't accurately use a solution to sub-bill your tenants. And so that's power monitoring, and then power quality.
Yes, on the power quality front, surely everyone is under the impression that it's down to UK Power Networks or any other DNO to provide clean power, correct?
Well, to some extent, yes, but generally there are a lot of safety risks with power quality, and these days, as well as safety, there's the cost of power outages, an increasingly data center biased world. And if those facilities are down for any period of time, then there's significant costs involved. So again, if you don't monitor your power quality, you don't know. And the problem with power quality is that a lot of the issues have the same symptoms. They tend to lead to nuisance tripping of breakers, nuisance RCD tripping, and if things get particularly bad, heat and fire risks. And most of those power quality issues, despite what people might think, actually arise within a facility. So with the rise of LED drivers and switch mode power supplies in computers and servers, you can generate a lot of noise within a facility. So you can be putting those problems back onto the grid. So when we talk about power quality, we're talking about typically about things like sags and swells, under voltage, over voltage, transients, short-term, momentary effects, under voltage, harmonic distortion, frequency, power factor, just to name but a few. So they're the main issues. So then it becomes more about where you monitor within your system to capture those events. So generally at the main incomer, you would have a power quality instrument, something like our Q800 or our DigiWare 100 or 200. The Q800 particularly, you can overlay the CBEMA curve, and it can produce an audit report in an EN 5160 format, which sounds like a lot of standards, but it's all about being able to give the report to your energy provider in a format that they'll understand. They won't negotiate in any other way if you don't have a report in that format. So at the main incomer, you would have those power quality meters. And then at a sub-distribution board, performance and monitoring devices, some metering devices at that level. And then at the distribution boards for the final outlets, you'll generally have metering, including the MID, particularly if you're going to sub-bill that any tenants. It's interesting talking about MID, as I did just a moment ago. MID is a measurement instrument directive, and it covers all meters, a taximeter, weights and measures, gas, water. So it applies, in our case, it's at the MID directive 003, active electrical energy meters. And the goal of MID is to protect against corruption because there's sub-billing going on, or it's your taxi fare. So the integrity of the instruments, the metering, calibration check facilities, and a greater guarantee of accuracy.
So if it's there to ensure accuracy, am I right in assuming that all MID components are subject to approval?
In fact, that's another good question. I think the only thing that's not included is the current sensor, which is a little bit strange. So the meter itself is tested for accuracy. But they're used always together with current sensors to measure, and those sensors are not included in the MID standard. So the only thing that exists is a recommendation from the Department for Business, Energy and Industrial Strategy, where it says the current sensor should be obviously of equal or better accuracy than the meter, so that the system maintains its accuracy. And then with our own product, DigiWare MID, you've got energy visualization. So the displays have an M to indicate that they're MID compliant. They have a software event log. It's a lot to do with software and protecting it from meddling. So there's an event log which can't be reset. So any config you change, any tampering is logged. If there's any software change, then that leads to a CRC error, which is a checksum for the software. And any of those config changes trigger a system alarm, got a flashing red LED, and there's an alarm detail event log that you can look at. And then the billing information itself is available either on the meter, or you can log in via Ethernet to the gateway and view that in a more easy-to-use form.
Do you have any examples of Socomec metering in use? What were the results of people using?
Just very briefly, there's a case study that one of the most significant at one of the London banks. And as is common industry practice at the moment, 1 meter per load, if you've got 60 plus 120 loads, that can lead to very large panels, 1 meter, 1 meter, 1 meter. They wanted to understand their energy use to guide future investment decisions. So the first issue they had was the physical space. So they started off with 9 meter panel boards, ending up at about 5.5 square meters, 20 meters per panel board. And they finished up with an 87% reduction in space using our DigiWare system, so that each display can measure 30 loads. So it drastically reduces the size of the panel. It also, you wouldn't think power consumption of electrical meters would be an issue, but when there's that many, at the beginning of this process, they were spending about £738 a year just powering these energy meters. And when they finished, they were down to £17.50, about a 96% reduction. So it makes a significant difference.
And this is quite a complex area. We are running out of time, but I just wanted to see, how easy is it, would you say, for our viewers who are thinking of these products to select the product that they need?
Well, the DigiWare system is easy to use, multi-branch metering system, but it's simplifying it. It would be using the meter selector tool. So we have an online tool that simplifies the selection. You effectively define the number of outgoing ways, their rating, you select the data you need to measure, and then it produces a single line diagram and a list of parts and a list price. So we try and make it as easy as possible.
Thank you, Alastair. Before we wrap up, just one quick line. What would you say the key takeaway from today is?
Look, if people didn't remember anything else, the only thing I would say is if you don't measure or monitor, you're just guessing. You don't know.
Perfect. Thank you very much, Alastair.
Thank you.